tagadan 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 pam pam tagadan 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 pam pam tagadan 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 pam pam tagadan tagadan pam pam tagadan 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 tagadan pam pam.
All right, as more people start to come in, one of our sponsors, X-Scale Solutions, is going to be presenting DK Panda again, extracting higher performance and scalability for HPC and AI applications. DK, thank you.
So good morning again, everybody. Yesterday, as I was telling, like I wore the Ohio State University hat, so I spoke about all the things what we do from the university side. So today I'll be wearing the company hat, and I'll be telling you like what we are doing, especially on this company, X-Scale Solutions. We have a booth. Some of you had stopped by. We also talked. So, so I'll first start with a very high-level overview of the company, if some of you are not familiar, and then I'll go into some of these products, what we have. And yesterday in the talk, I touched a little bit about the X-ScaleAI-DPU. Today, I'll be going into much more details on that. But in addition to that, we also have like an X-ScaleAI, X-ScaleAI with a DPU, X-Scale HPC. So I'll be giving an overview of these products, and depending on your need, we'll be very happy to talk. So just to give a very broad perspective, yesterday, as I was telling, like from the Ohio State University side, we have been working on the MAPIS-2, all the big data and machine learning stacks and all for the last 22 years. So as those softwares people have started using, so we received a lot of requests really to provide commercial support. So that's how this company started. We started in 2018, around 4.5 years back. And over the years, we have done some transformation here, and I'll be trying to mention that. But the broad goal or the objective is to really bring innovative and efficient end-to-end solutions, services, support, and training to the customers. So we started with the basic commercial support. I mean, you can always download the libraries from the Ohio State University site. But of course, I mean, if you really want to get the best performance on a given platform or for an application, you need to do a lot of tuning kind of things. And this is what actually we provide to many different national laboratories and international HPC centers. That is one part of the company. And here, just to highlight some of these things, as many of you know, those of you are familiar with MPI library, there are so many parameters. Any MPI library, almost like 100 to 200 parameters are there. So if you are deploying, let's say, a very latest hardware, or if you have like 5 different kinds of hardware, if you just use the default version, you may not exploit the best performance. Okay? So this is where like we come in. We can do actually platform-specific optimizations and tuning so that all your users get very good performance. And we have like a different kinds of support, service level agreements. But another thing is this application-specific optimizations. So if, let's say, in your organization or HPC center, you just, like there are 2 or 3 killer applications, and you want to really get the best performance out of there, so we can actually work with you for a given application, because all the application, you know, the MPI application, there are all different kinds of communication characteristics, point-to-point, collectives, and all those things. And we can actually work with your application scientist and exactly say, okay, for running this application on this platform, choose these 10 to 20 parameters, and then you will see you will get a boost in the performance. Okay. So those are the kind of the things what we are trying to do here, and we work with directly with the end organization, also with work with third party, like integrators, systems vendors, so all those opportunities exist, kind of things here. But then what has happened, as we have got engaged over the last several years with many organizations, people have been asking much more like a value-added products. Okay, like whatever is available from Ohio State University side, can those be expanded into newer products? We call it like a value-added products. And these are being done, if some of you are familiar, like in the US, Department of Energy has several grants. They are dedicated for companies. These are called Small Business Innovative Research Grants. These are not the research grants like you get from the universities, but companies you can actually get. And we have got many of these grants to really take the state of the art, whatever is available from the Ohio State University side, and really convert it to real products and market these products with commercial support. We also are members of the Open Power Consortium, etc. So that's what I'll be spending a little bit more time here. And so we have currently these are the 4 products which are there. The X-ScaleAI-DPU is the base one. It is just like on that commercial model, as I was telling, like we can tune a lot of parameters given your platforms. Let's say tomorrow you are buying some InfiniBand STR400 with some kind of AMD Milan. We can exactly tune those things, the library, and then give it to you. Okay, so that you can actually run those on your systems, if it's depending on the GPUs, all those things we can do. So these are like out-of-the-box fine-tuned and optimizations for all different kinds of systems. So that is kind of our base product. But let's spend a little bit more time on the MAPs to DPU. I know Gilad provided a very high-level overview. My job becomes much more easier now. Yesterday, I introduced that, but let's go into a little bit more details because this is where the DPU technology is gaining a lot of traction. So in that context, I'll introduce these blocking collectives. You remember yesterday, those of you who were here, I gave this example, like let's say you want to go with your friend for a movie, okay? You try to synchronize. Now the question is, do you just sit idle, waiting for your friend to come, or you want to do certain things while your friend is coming? Okay, so that is like a blocking versus non-blocking. And that's what happens within MPI library. If you see this blocking operation, so let's say these are the processors, and you run the computation, and let's say you call some collectives. There are all different collectives in the MPI standard. If those are familiar, let's say all-to-all, all-to-all-V, broadcast, reduce, all those things. And as the system size grows, and especially with the blocking collectives, irrespective of which algorithms you use, still it takes some finite amount of time. And the blocking semantics says that unless this operation is done, the processors are not making anything. They're just spinning. They're just checking for the completion, or they might be actually helping with the collectives, because collectives many times, you do a lot of data exchange. You send it to me, I can actually put them together, send it to others. So that's what they're trying to do, the communication. They're not doing any computation, okay? So that used to be the blocking collectives, and of course it has been there. I mean, still a lot of applications use those blocking collectives, but as the system size grows, you will see that you will not get very good efficiency or speed up, okay? Because there is no overlap of computation and communication, and that's what many times you will see that your job is not scaling. Okay, so in that context, MPI 3.1 standard introduced these concepts of non-blocking collectives. Okay, for every collective, like let's say all-to-all, there is something called an I all-to-all, which is a non-blocking version. Similarly, reduce, I all reduce. So what it means that, like that example, whatever I indicated, while you are waiting or the communications is going on the background, you can actually proceed with the computation. Okay, so that is the whole idea of the non-blocking. So let's see this animation. So it is exactly similar to like the previous slide, but now you will see that, let's say you schedule some operation, like a communication operation, and while the communication is happening, of course you may need to check whether that operation is being completed or not, but you can actually introduce computation there. Is that clear? So that is the very broad difference between the blocking and the non-blocking. So like this, if I can do, then of course I'll be spending a little bit of time doing this completion checking, but you will see that there is a lot of this overlap I can achieve or exploit, and then overall my execution time will reduce. Okay? So now the question is, of course, this has been in the standard, in MPI standard for many years. People have been doing, and I think Gilad touched on that. Let's say you have like let's say AMD Milan with 128 cores. People try to write some jobs saying, okay, might be 120 cores are being used for computation. I dedicate 8 more cores to do this kind of asynchronous progress. Okay, you need some resources. Okay, but if it is a fully subscribed, like I want to use, the application wants to use all the cores, then the question is who will doing this progress. Okay, and then If I cannot do that, then of course I cannot get this good overlap. And this is where the catch is that who will make this progress in the communication. And this is where the DPU really comes very handy. Okay? So if you take a look at the DPU architecture, Gilad mentioned quite a lot, and I also mentioned yesterday, think of like these are executives and these are assistants. Okay? So the main processors are executives, and then these ARM cores, whatever is available on the DPU, whether it's a Bluefield 2 or Bluefield 3, think of them as assistants, and just like in the real world, assistants actually help the executives to schedule conference calls, or let's say video calls, or send mails, get the results kind of things. You can achieve the same kind of things within MPI library. Okay? So that's what I'll first talk about, how to redesign an MPI library to take advantage of the DPUs and accelerate your scientific applications. And later on, I'll give actually some example in the X-ScaleAI-DPU product. You can also offload some computation. But it doesn't have to be very powerful, because these ARM cores are not very powerful, so you cannot totally offload everything. But up to a certain extent, you can offload. And also, I'll try to show, I think, very recent things we have done. You can also offload checkpointing kind of things. Your DPU is good for that. Okay, I'll show you results with those. So now the question is, now this is a high-level thing. So just like, think of like these assistants. Now you have RDMA. So typically, you know, the RDMA concept has been there. I can take data from the host memory and send it to others. Okay. So now, how do I give, or how do I take help from the assistants or the ARM cores to achieve that? Okay. So this is where some APIs comes into picture. And last year, NVIDIA had only the stage transfer mode. Okay. So that means if I have like this DPU memory, instead of the host sending from this host memory to this host memory, the DPU, I can do a RDMA read followed by an RDMA write. Okay. But then you will see that, those if you're familiar, there is a copy involved here. Okay. So that kind of design may not scale. Okay. But in the last several months, there is a new GBMI interface has come, so where I can directly tell DPU, like I give these pointers and the keys, I tell, okay, this DPU saying, okay, take data from here and then put it here. Okay, so this is the very latest API, and that's what I'll be trying to show the results here. And with that, actually, you don't need to have a copy. Of course, the setting it up, you have to do a little bit more work here, but then the actual data transfer operation becomes much more faster. Okay? And with that, actually, yesterday I mentioned, like over the weekend, we actually made this, the MHAPIS2 DPU is actually being designed from this company side, X-Scale Solutions. So there is we made a release of 2023-04. And this is based on the MHAPIS2 237, which is very latest version. And we use this, all the GBMI-based framework. And today I'll just try to show the IOL12. Our last year version, which was based on the staging, had also other collectives. We are gradually bringing those collectives. In the next few months, you will see those things. So first thing is this overlap, okay? And also Gilad mentioned about that. So the basic MPI library, if you take a look here, this is the overlap versus the message sizes. Those of you who are familiar with the MPI internal designs, especially short messages, we do copy-based things. Okay, so that means the CPU copies it, then you don't get a lot of overlap. And large messages, you basically go through rendezvous protocols. Like I send an RTS, you send me an CTS, then only I do the data transfer. You don't get any overlap. But if I can overlap, if I can offload that with the DPU, see the number, you get almost like a 98%, 100% overlap. That is the whole idea of this DPU. So that means I can overlap. Just like in the day-to-day world, the executives can offload things to their assistants. So while the assistants are trying to take care of the behind-the-scene tasks, the executives are continuing with their work. So that means I'm getting 100% overlap. Okay. So then let's see what is the impact on those collectives. Okay. Now this is a little bit tricky. Let me give a nice example. You will see. Go back to my yesterday's example, like your friends you want to sync up to go for a movie, okay? So depending on where your friend stays, okay? So let's say might be your friend is coming 5 minutes distance or 10 minutes distance or 15 minutes distance, you need to have a reasonable amount of work there, okay? So if your friend is 5 minutes apart and you exactly schedule saying, okay, I give him a call, or a call saying, yeah, get started, and I have 5 minutes of work, then I will get complete overlap. Okay? But if my work takes 10 minutes and the friend already arrives, that's not a complete overlap. Everybody's getting? Or if it is less than 5 minutes, let's say I just finished or allowed 2 minutes of work for myself, then after that I am sitting idle for 3 minutes. That is also not good overlap. Okay? So depending on your communication pattern, I'll try to show you a lot of results later on, especially for application. You need to redesign because every application has their own characteristics, own communication patterns, and you need to redesign them properly to get the best performance. Okay? So we'll start with the basic collectives. So in this case, all-to-all. This is taking place with 32 nodes, and this is the Bluefield 2. Okay, so I'll show you all the Bluefield 2 results. We have just started working on the Bluefield 3, and this is 100 gigabits, and these are connected with the Intel platforms. Okay, these are on the HP CAC systems we are running. Now see this, so this is like a 512 process run, and this is a 1000 process run, and these are the message sizes. That means I'm trying to do an IO12 4K, 8K, 16K, 32K, and same thing here. See the performance improvement, or rather the total execution time. Okay? When I combine my computation time plus communication time, I get almost 84% improvement here. Okay? Because the basic MF is 2. If you see these red bars, that doesn't have this overlap capability. I cannot put it to the DPU, so I cannot accelerate it, but with the DPU, if I can offload, then I get the good overlap. Now with the large messages, especially with this GBMI, because directly I'm copying from the host memory to the other host memory, in fact, it can scale actually. And we have seen, here you see almost like a 512 kilobyte. In fact, you can go even beyond 1 megabyte, 2 megabytes, 4 megabytes kind of things. And you see the benefits here, 46%, 47%, just at the collective levels. Okay? So, and then this is another AMD platform also. And this is a Bluefield 2 with a 200 gigabits. Adapter, again with the large messages, we see very similar kind of like a 30%, 35% improvement. They're just at the collectives. So then we actually worked with one of the application, I think Gilad mentioned in his talk also, P3DFFT. So this is where like we worked with the P3DFFT developer many years back, even before all these DPUs came. So there was a version earlier, the P3DFFT was written with blocking collectives. We worked with him to make it to change to non-blocking collective so that he could rearrange those computation. Okay? Instead of doing all the computation and sending the all-to-all, you can do actually some computation, do I all-to-all, and while all-to-all is happening, you can do the remaining part of the computation. And the whole idea is to really have the good overlap. And here if you see, this is running on a 32 nodes with 32 ppm, like 1,000 process runs with and especially FFT also, if those of you are familiar, like you have to also define a process grid. So this is being done with the 32 by 32 process grid. And then here you see, at the P3DFFT application level, we're getting around 24% benefits. And these are different grid sizes. These are very large grid sizes, 1K by 1K by 1K to 2K by 2K by 4K. We almost saturate the host memory completely. Okay? But interestingly, if you take a look, so these are with large messages, and yesterday actually they are very fresh numbers. Gilad, you have not seen this. Yesterday night's number. We actually tried to look at not only on the large message sizes, but small message sizes. Okay, because P3DFFT you can run over all different grid sizes, and here itself, I mean, these are not very small, like a 128 by 128 by 128, like a 2 million elements. These are not really small, and running out on 8 nodes with 32 ppm, and look at the number, 47%, 48% I can get. Okay, I don't think anybody else has shown this kind of benefits yet. Okay, and these are real numbers. I mean, you can run it on a 256 process. Many times you run these kind of jobs on your system or on cloud, and you can get 48% benefits in this kind of environment. So this product, as I just said, it is being already announced. I mean, if you want to use it, just send us a note. Again, this is a commercial product. We give trial licenses, so you can actually go and then use it, and if that is good for you, then we can talk about things. But this is the best numbers so far we have got, the 48% here. Any quick questions before I go to the other ones? People are all awake. We had a coffee break. Is the concept clear how we are trying to take advantage of the DPU? Okay. So then, yeah, any questions? Okay, so then let me go into the two additional products we have. This is the X-ScaleAI. Those of you who attended yesterday's talk, you remember I gave an example of like a, yeah, go ahead.
Maybe just one comment.
Yeah, sure.
For HPC, it's essentially a new thing, right? And that's why sometimes you don't see so many questions coming up, because people still trying to understand DPUs and why should they bring DPUs in the HPC in that sense. Now, I believe that DPUs will become the de facto NIC in every HPC platform in the future. It's definitely become a de facto on every cloud infrastructure. And now it will become a de facto on every HPC infrastructure because of the ability to improve MPI performance and with that to improve application performance. One of the questions that we get or we're seeing, and that might help people to kind of understand why it makes sense, DPU is a device that is more expensive than a NIC. It has its premium because a DPU, it's a full computer by itself. On the other side, when we're talking about 1.2x and you can have showed even more, a 1.2x performance improvement on a supercomputer, the benefits there, it's much higher than a cost of a DPU, kind of replacing the entire DPU in a system. And therefore, it's completely paid for itself. If you're talking about 1.2x performance improvement, it's almost 1.2x also performance per dollar on the data center from investment perspective, and it's 1.19, so almost 1.2x also performance per power consumption. So the math is completely there, the TCO story is completely there, and that's why DPUs will become the de facto. It's even more than that because every sessions on DPUs, you're kind of seeing more things that can be done with a DPU in an HPC infrastructure. It's not just MPI, but you can do more. You can think about a DPU is thinking about first generations of iPhones or second generation or whatever. You had phones that were just used for phones, and that's kind of network or NIC that is just using as a NIC. DPUs enables you to actually put services and applications on the DPU. So once you have a DPU in the system, you know that over the time of the system, there are more and more services that will be created, not just those elements or specific MPI, but you can do much more. So that's kind of a great investment to that. I don't know if I can call Mark name, but you can probably put some good word about what the DPU can be used in the future. But that's kind of the future of HPC, and that's why it's such important. That's why we see a lot of development around it.
So thanks, Gilad, for adding those comments. So let me move ahead. So this is the X-ScaleAI. So this is where, like yesterday, I talked about like a based on MPI, you can actually link it with Horoword, then you can provide a complete solution like a TensorFlow PyTorch, and that's what this X-ScaleAI does. It already builds everything together, and you can actually link it with, we have linked it with our MVPs to GDR library. So this is a product. So you can just download and just install, and it runs for all your AI applications. And more interestingly, what we have provided here is actually there is also a visualizer, like you can actually do profiling and introspection support. I'll go into a little bit more details on that. So these are all the different system configuration. I'll just try to show some performance improvements we have done. These are like let's say 2 node, 8 GPUs per node. This is what the green lines people typically they have been using, the standard Horoword. Everybody just download Horowords and then run. Whereas this X-ScaleAI package is actually optimizing a lot of those parameters And even in the like 16 GPU case, you can see we can improve the performance by 35%. These are another configuration, similar kind of things. ResNet 50 with a 37% improvement. This is a configuration 3, 50%. Like this, you can directly from this install the X-ScaleAI, and you will see that your DL training jobs are actually getting better and better performance. But this is actually what we have done is an introspection. So many times when you run this, a lot of deep learning applications, there is a lot of collectives actually determine the performance, like the all reduce. So this profiler actually think of like a car dashboard. As you are driving, you can find out like how much my mileage, at what speed I'm going. So this is what actually does for a DL training. So you can actually find out how many all reduces are happening, which all reduce is getting slowed down. Okay, so that means that all reduce algorithm is not correct. So then you can quickly go and then fix that algorithm, and you will see you will get a boost in the performance. Okay, so we have done that integration here, and in fact we have done some studies with some of the customers, like this kind of things to get really by any programmer, it takes several days. Okay, whereas this tool will only give you very quick answers. Okay, why your DL training is being slowed down, and even in a half day, we have seen some with our customers, we can actually boost the performance by almost factor of 1.3x. Instead of like spending 2 weeks trying to debug where my training is being slowed down or why, we can actually give this kind of an answer. These are another use case too, similar kind of things. In the beginning, you can think theoretically, let's say you can get like a 370,000 images per second, but actually you start getting like a 181,000. Then you break your head saying, okay, where I'm losing my performance? And using those kind of profiler, you can actually fix your things and get back to the desired value. The other thing is when the DL training many times, because it runs for several days, you also need checkpointing. Okay, the PyTorch, those of you are familiar, it has actually a checkpointing scheme, but these are very naive schemes, and they don't scale. So this is what actually here you will see. This is as the number of GPUs increase, look at the green line. Your percentage overhead for checkpointing is continuously increasing. Okay, whereas here what we have introduced our own checkpointing schemes based on SCR, Scalable Checkpoint Restart. So that is a library from Lawrence Livermore National Lab. So we have actually integrated that here to improve the checkpoint restart performance. Here you will see. So this is actually another similar things. The checkpoint performance here. This is for the PyTorch over a hoverboard. So altogether, this is actually a product. It can actually really help you. If you are really running some large-scale DL training on GPUs, you will be able to boost your performance and scalability in a significant manner. So the final one, what I want to show, this is again coming back to the DPU. You will see very new things here. What we have done, two major innovation. In the MPI library, we said offload communication. So here I'll try to show two things. You can offload computation also. Okay, and this is also very last 2-3 weeks we have done. We have not talked about this earlier. Even the checkpointing you can offload. I think Gilad mentioned about services. You can, instead of the host trying to do the checkpointing, you can actually ask the DPU to do the checkpointing. Okay, so that means that checkpointing is totally comes outside of your critical path. Okay, and that gives to the boost in the performance. So this is available as an X-ScaleAI-DPU package. At this time, the checkpointing is not integrated. I think we'll do it in the next month or so, but I'll show you the results. So, but this one is available, the basic thing, CPU-based DNN training, based on Horoward and MHAPIS 2. And so here you will see like a ResNet 20v1 model. So typical DL training, sometimes you also do validation, you do fetching, you do testing. So some of these operations which are not consuming a lot of CPU resources, you can give it to your DPU. The DPUs are not powerful, so we have done a balanced distribution kind of things. What can run on CPU, what can run on the DPU, so that you get overlap in those computation. And then here you will see this is the Bluefield 2. We are hoping Bluefield 3 will get even better performance here, around 17%. We can give a boost in your training. Similarly, this is a tiny ImageNet data set. Here we get around like a 14% improvement. Okay. Now these are very latest results. So now think of like a DPU checkpointing. Okay. Earlier, I indicated the regular checkpointing, you can have SCR, those kind of designs, but still the CPU is to do it. So if you take a look at this, any DN training, you have the forward-backward pass, and typically you do this storing to a checkpoint. So at that time, everybody is stalled. Okay. The CPUs are not able to make progress. But now if I can offload that to the DPU, so this is like a checkpoint restart service, think of, and then now I can continue. So I just let these DPUs try to do this operation in the background while I keep on moving forward. And these are some of the numbers. So depending on, again, at what frequency you do your checkpointing, it will determine there. So here we studied like two things. One is a less frequent, like a 4x, which is more on a stable HPC cloud systems, or there is a more frequency like a 10x, where things are not very stable. Okay. So here, if you take a look at the numbers here, 2 nodes to 8 nodes, look at, I can totally, this is like the root checkpoint, that is like the baseline. Compared to that, by offloading, you get almost 41%, 49% benefits kind of things. Okay. So your DL training is actually running much faster, and this is also another similar kind of studies. Here, this is on the ResNet 50 and ResNet 152. Again, if you are scaling here, almost like a 50% time, you can actually accelerate. Okay, so these are the kind of the newer services we have here, and as I said, this will be available in the next release, this checkpointing service. So to conclude, here I just provided an overview of all these products and services, whatever is available from the X-Scale solution side, in addition to the regular like a commercial support, but these are all the value-added products. So these are based on whatever from the OSU side you get, and these are the real commercial products where we are trying to really boost the performance for all the HPC and AI applications while exploiting all the modern CPU, GPU, and DPU technologies. So if you are interested, I'll be very happy to talk with you. And again, some of you had stopped by. We have the booth on the next side. I'll be here today totally, so please feel free to stop by. And that's all. I have here, these are all the contact points. You can send it to me directly, or also we have a contact us email. You can send a note. So I'll just stop here, and if there are any quick questions, I'll be happy to answer. Otherwise, we can talk during the breaks. Thank you.
Pam